our meeting. Hello, everyone. Thanks for joining us today. Welcome to our Energy Code Implementation Series with 2025 code updates. And today we have instructor Jennifer Rennick from Inbound Screen Consulting, and we will be going over single-family buildings. My name is Danica with 3C Run from the County of San Luis Obispo. And before I pass things off to Jennifer, I have a few logistical slides to go over. Next slide, please. Just a few quick Zoom reminders before we get started. Please make sure you're on mute for the duration of the training. We highly encourage questions, and if you have any questions that come up, feel free to put them in the chat, or you can raise your hand and we can unmute you. This session is being recorded, which will be shared with you along with the slides in the next few days. And just a few quick words about who we are. We are the Tri-County Regional Energy Network, also known as 3C REN. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. 3C REN is funded by ratepayer dollars collected through the public goods charge found on our utility bills, and the benefit of being ratepayer funded is that there is no cost to those we serve. And as a regional energy network, we are able to return these funds into our local economy, which has historically missed out on these funds. Next slide, please. 3C REN currently offers 6 programs focused on 3 services: incentives, training, and technical assistance. Our training today is part of the Energy Code Connect program, and you can find additional trainings and learn more about our other services by visiting 3c-ren.org. And with that, I will hand it over to Jennifer to start today's training.
Thanks, Danica.
Yeah.
Hi, everybody, and welcome. I'm Jennifer Rennick. I'm a licensed architect and certified energy analyst, so the CEA, same as Danica from Quebec. And today we are on the second part of Energy Code Implementation Series, and we'll specifically go over the single family new construction. Next time we'll touch on single family additions and alterations, and then the ADUs, and then finally we'll end with multifamily. There are learning units. If you need AIA learning units or ICC learning units, this class qualifies, as well as the rest in our series. And today we're going to go through a kind of a quick 2025 Energy Code kind of overview, just to remind folks that the new code's coming up. And then I'll touch on some of the single family residential kind of high level changes. And really, I'm looking at our current code and then giving you a heads up on what's going to be coming up in 2025. And then some of the topics that we're going to touch on today has to do with domestic hot water. We'll talk a little bit about attics and roof insulation, windows, battery and electric ready, heat pumps for space conditioning, and indoor air quality ventilation. So there's just a little bit that's changed on each of those, and a lot of it actually staying the same in terms of like some of those explicit requirements that you would see as an architect. And if you're trying to comply with the energy code, a lot has not changed. So that's kind of the good news. But there's a few things, kind of big picture, that I also want you to be aware of. So I'm going to go through that. Feel free to put your questions in the chat. Danica is going to help me monitor it. So if I don't see it, Danica will stop me, and I'll try and answer the questions as we go. Otherwise, we'll answer questions at the end. Big picture reminder, the new energy code for 2025, or the whole, building code's going to go into effect January 1st, 2026. And I put a link here for the documents available at energy.ca.gov. You're going to get a copy of the slides, so you'll have that link. For 2025, the whole idea is that the energy code would go into effect, and it would encourage more energy efficient heat pump technology, both for space heating and water heating. There's some expanded PV system and battery storage standards, although that really didn't impact residential single family. So that was more of a non-res and multifamily. There's some improvement on indoor air quality by strengthening the ventilation standards, which is something we'll talk about today. And there is a kind of an energy water nexus. And this, again, mostly is hitting on the non-residential codes. And it has to do with your heat pump requirements, but also new requirements for chillers and cooling towers. But the big picture is that all this is estimated to save the state $4.8 billion in energy production. It's a multi-year process to adopt each 3-year code cycle, and this gives you an idea of even the 2025 code cycle. We were starting it back in March 2022. So right now we're working on, we'll be working on the codes for coming up in 3 years, even after the 2025 code. And so January 1st coming up is when we'll have this new code. The code is comprised of the standards, there's reference appendices, and then there's several manuals that are useful in terms of understanding the code, with sample questions, sample situations in both the compliance manuals. And then you can, if you're so inclined, you can read up on how the algorithms in the software are mandated to calculate some of these things for performance method. And the next code cycle will also have these manuals available. Under this code, we're having the same code organization. So those of you who've been kind of paying attention to the code, like under the 2019 cycle, we didn't have the multifamily residential subchapter 10, 11, 12, but that got introduced under 2022. And then under 2025, we still have the subchapters. And about the only thing that changed for 2025 in terms of this is that we have laboratory now as an occupancy type in the top level of subchapter 1 and 2 was added because now it's addressed in the non-residential sections. And today we're just going to focus on chapters 7 and 8 and a little bit on occupancy types or mandatory measures that affect all occupancy types, specifically for heat pump water heaters. There's a great table in the code, table 100 at the beginning of it, that is very useful for knowing where to go into the code specifically for certain applications. So I know I found this table useful, and it's always helpful when you're first learning the code, because remembering how our energy code is organized as a separate entity in and of itself is, it takes some practice. Let me put it that way. And it's not organized the way the rest of the building code is organized. So this table is super handy to have available. Okay, some of the kind of big picture changes now for the energy code. This just sort of a comparison, because we're in the 2022 code right now. And one of those big changes at the time was that we had this new performance metric, a performance method, meaning if you're going to do your computer modeling, you would have something called an EDR rating or EDR metric. And we kind of wrapped our brain around that for the past few years. And that's what would show up on your Title 24 report if you're doing it performance-based. And our baseline was basically heat pump water heaters and heat pumps for space conditioning. There was some attic insulation, things to know about the new kitchen range, hood, airflow rates, ventilation, electric ready, battery ready, etc. And so a lot of the changes under 2019, basically things that you could do for credit now became mandatory under 2022. And then wouldn't you know it, under the 2025 code change, the EDR metric we just wrapped our brain around is being scratched. It's being replaced. So I'll tell you about that. It's really not that complicated, but just heads up. If you're working under the current code, you're going to hear, you have to look at your EDR. And then under the new code, it's going to be a different metric, which we'll go over. There's been a little bit of update revision on the IAQ ventilation, specifically with accessing the equipment for balanced ventilation or supply only ventilation. We'll go over that. And there's been a little bit of expansion on some of the prescriptive requirements and a little bit of increase of insulation for your roofs, your attics. And that's about it. So there really isn't a lot of big changes for single family residential new construction. So that's the good news. And as a reminder, the mandatory measures are applicable to all the projects and their energy efficiency measures. The prescriptive component package are applicable to projects when you do it as a whole that way. It's essentially a checklist approach. It's like following a recipe. And then if you are a creative cook and you like to mix it up when you cook, then you can do that, but you would move to the performance method, which is your energy or computer modeling. And there you're allowed to have trade-offs. And so as we go through it, I tried to color code a lot of these with orange being mandatory, blue reminding you it's a prescriptive component, and then the gray for performance or computer method. Now, the new metric that is replacing EDR is the LSC, or the long-term system costs. And really, we're looking at it as like a dollar value per square foot. However, that LSC does not represent a prediction of individual utility bills. It is a metric of cost that is a cost to the state and kind of a cost overall in the actual production of the electricity itself compared to sort of that cost of production of using that energy in the building. So we'll have a metric for the long-term system costs that includes electricity, but also gas or propane is part of that metric. And there's going to be an efficiency component, which includes your space conditioning system, your water heating system, mechanical ventilation. And then there's going to be a total LSC, which has your PVs, your battery, if you include it, lighting, and other plug loads. And then source energy, very similar to what we have, other than it's similar in that it is taking into account the source energy or the source impact of burning fossil fuels in order to either heat the building or heat the water directly, or burning fossil fuels in peaker plants that are used to generate electricity. And so the old one would say is, okay, source energy was a proxy for carbon. In a way, it's similar, but it is taking into account how fossil fuels are used directly. And so like, our current situation, let's say you're doing a computer model, you get your Title 24 report, you're working with your consultant, you would have basically, you would know the building complies if all three metrics, your efficiency metric was better than your proposed design, your total EDR was better than your proposed design, and that source energy or source metric was better than your proposed design was better than the standard or baseline design. Sorry about that. I flipped those. So when your proposed design performs better, meaning less energy, like a Gulf score, lower points better, then your building complies. And now we're basically just kind of replacing those with long-term cost savings, efficiency, long-term cost savings total, and another source energy. And when it comes to the new construction, those things line up just like in the chart we had. And then our additions and alterations, we were still using TDV or are still using TDV under the current code cycle 2022, but coming up under 2025, that TDV for additions and alterations will just be the long-term system cost efficiency. And those are, again, kind of based on dollars per square foot versus a ranking score, which we had under this code cycle. I'm sure as we dig more into all this and start to practice with the new software, some of these things will fall out, and we'll do more trainings on that. Okay, the other thing to kind of just be aware of, another sort of vocabulary change, is HERS, our HERS rater. Go out and do your blower door testing, duct leakage testing, maybe do verification on your refrigerant charge and assist with the CF2Rs, CF3Rs that are needed for permitting. Now the HERS rater is going to be called an ECC rater, Energy Code Compliance Rater. Okay, so new name, same job, but new name. So under the current system, our HERS and everything about HERS really followed under Title 20. And what the current code cycle has done is moved that into Title 24, Article 1. There's a new section really dealing with what the HERS rater was doing. So when they pulled that into our Title 24, they also gave it a new name, Energy Code Compliance Rater. And they'll still do field verification and diagnostic testing, but you'll see in the code the word HERS has been dropped out of everything, and you'll see acronym FV and DT used, and that just is field verification and diagnostic testing. And then the other thing that is new is that there's a quality assurance review and an audit process now being put in place for the ECC rater. And the ECC rater can even achieve something that's called an exemplary status. So the idea with all this new code change is also to get that ECC rater really showing that they are doing the job that they were trained for. And also as a consumer, we can look for someone who has exemplary status and know that we're getting a good job done on our project. With the performance computer modeling, the main key takeaway was that our standard design or our baseline design was now including efficient, electric heat pump, space heating, and heat pump water heaters. But there were some prescriptive situations where you could use gas water heating. And so under the 2025 code, I just want to give you a heads up that these new kind of prescriptive requirements, again, when you're following the recipe card approach or the checklist approach, and also being used as the baseline for your computer modeling, heat pump space conditioning is the new base. So gas isn't applicable anymore. Heat pump refrigerant charge verification is new, and that's going to apply to all the climate zones. Fault indicator display is required if you're installing an energy or heat recovery ventilation system. And again, the ECC rater will field verify this. And heat pump water heaters are now the baseline. And so you can still use gas water heating if you want, and you can use gas appliances for space conditioning, but you will have to automatically use the performance method. Now, most of the people we work with are using performance method anyway, but it's good to know that this is what you're going to be compared to. Okay, some of the biggest changes for the code really has to do with domestic hot water, and it's not earth-shattering, but the idea is that it's more definitions and more requirements for folks. So the CEC, California Energy Commission, writing the energy code, they have included a lot more definitions in the 2025 version of the energy code, and partly because these are the types of water heaters that are being seen. So they're just put in writing what each of these types actually mean. So I think it's a useful to have. You're going to get a copy of the slides. Kind of the main, I think, thing to know is our heat pump water heater that's an integrated type is often abbreviated HPWH. And so specifically, we're going to be talking about like the type of heat pump water heater where the heat pump itself is on top of or next to the tank of hot water. And then split system would be basically a picture of everything else you're looking. It is a type of split system. And then there are certain systems that are split refrigerant, which means you've got refrigerant actually passing between the condensing unit and the tank of water with the heat exchanger, or the split hydronic system, which is usually what we see in our area for residential, which would be like the Sandin system, where it's water that goes back and forth between the condensing unit and the tank. And this is an example of now, just FYI, so you're on the same page with the vocabulary that you might be hearing or seeing, is a split hydronic heat pump water heater system, meaning you've got the compressors separate from your tanks of hot water, and there's a hydronic circuit line that goes back and forth between the tank and the heat pump. Now that is going to be different than like a split system that is also an air to water heat pump, where in this case we have a refrigerant line that is going oh, I'm sorry. This particular example with the Solstice monoblock is using hot water, not refrigerant through the house, but you can have both types. And in this case, this is an example of on the right where hot or cold water would circulate. But the idea with this, and something you might see more, is this type of system doesn't just heat the tank of hot water, it can also send, depending on your system, hot water or refrigerant to the indoor heating and cooling units. Okay, and hang on for 1 second. There we go.
Hey,
I
Jennifer.
think, yes,
We have a question in the
yes.
chat from David, and he says that I have been using small heat pump space heating and cooling units that are self-contained. Refrigerant charge is already in the unit. How would the refrigerant charge verification work?
Small heat pump space heating. Usually, if you're getting like a do-it-yourself where it is already charged, that is one of those things where you would have that now currently, like the HERS rater, they may come out and they look, basically look over the shoulder of the person installing it and say, yep, it's already in there. It's kind of a little bit of a, look over your shoulder and go, yeah, okay, I verified that so that it's in there system. But then the other ones where you're actively, the person doing the install actively has to have the appropriate licensure to handle refrigerant and is doing it. Same sort of thing, though. You want to call your HERS rater while that person is doing it. So again, the HERS rater can look over the shoulder at the same time and see that it was all charged properly. So I hope that answers your question, but it's, most of those requirements are really set up for the systems that will be energized at the time. Okay, you can let me know in the chat if we didn't get your question answered, but that's a good question because more and more, a lot of folks are opting for do-it-yourself pre-charged refrigerant lines and pre-charged units. And that's just for the space conditioning. The water heaters, self-contained, no one's looking to see that these systems are charged properly. It's really meant for the systems that are running refrigerant line. The lines need to be charged, the unit needs to be charged, and it all has to be charged properly or it doesn't function properly. When it comes to a heat pump, water heater, this integrated type, there are design considerations that the homeowner should know about, the architect should understand, the person doing the install should understand. And the main thing with these that we're learning is a lot of folks, a lot of builders, a lot of people weren't quite realizing how much cubic feet of volume some of these heat pump water heaters needed. And some of the newer ones only need about 450 cubic feet of open space around the unit. And also there were some folks not understanding that the operating temperature on a lot of these were starting around 45 degrees Fahrenheit, but a lot of models now are going to 37 degrees Fahrenheit. So if the space is too cold, the heat pump water heater would automatically kick into electric resistance mode. So you wouldn't be getting the full benefit of the heat pump. So one of the things that happened under the new code is a lot of these kind of design considerations are being put into mandatory requirements that these things are looked at. So we still have the code requirements for energy code. And then also our plumbing code kicks in in chapter 3 and chapter 5 on how all these systems are installed. Their electric code comes in And so when taken all together, then you're going to have kind of the successful installation. But the energy code specifically picked up on some of the aspects that the plumbing code and electric code did not address. But taken together, all three go into our heat pump water heating systems. Now, under the 2025 code, under section 110.3, and this is mandatory requirements for all occupancy types, section 7, air source heat pump water heaters was added. So this is new. So the next few slides I'm going to show you is the new stuff. And it basically says, hey, your heat pump water heater has to have a backup heat source. In other words, something needs to kick in case the heat pump water heater can't function at cold temperatures. Most of the tanks have electric elements built in, but I have seen a project where that wasn't the case, and so they added another split system, mini split, to heat the space in case it got cold. So the code doesn't say you can't do it, but it says you need a backup. But most of them will have electric elements built into the tank that can function as the backup. And then what I alluded to before, you have to have enough ventilation around or open air space around the heat pump so the compressor can function properly. Because as that compressor on the top of the tank functions, it's extracting the heat out of the air, putting that heat into the tank of hot water, and it's ejecting cold air, essentially cooled off air as it pulls the heat. So you can, in a small space, it's possible to over chill a room, and then the heat pump won't function as well. So a lot of ventilation is useful. So what's mandatory now is they say, okay, if you install a heat pump water heater without ducts, we're going to give you an equation and we're going to give you some guidelines to follow that will tell you how much net free ventilation area you need in a door, for example, from the closet that communicates to a larger space. Or we're going to give you some guidelines on how much cubic feet per kBTU hour of compressor capacity you have, or follow the manufacturer, whichever is greater. So just, I could give you a kind of a heads up that most of the time you're going to be following what the manufacturer tells you. But this is sort of a a little bit more, gives you a little bit more guidance. And then for the net free area, this one might come in handy, but I have looked at it a couple of times, and it does seem that in most cases, if you have a nice wide door that's fully louvered, you'll meet this requirement. And then kind of a rule of thumb, it's hard to find on a lot of the specs right now what the compressor capacity is for a lot of these heat pumps, but Rheem, for example, prints it, and a lot of them have similar size systems, and so that's a 4.2 kBTU hour compressor capacity. And so if you end up taking that 4.2 and multiplying it times 100 cubic feet, you're going to end up with a space that's a 420 cubic feet closet. And I could tell you that that unit, when you read the specs, it requires more than that. And same with the A.O. Smith, even the newer ones are 450 cubic feet. So I think for the most case, you're just going to follow the manufacturer. So don't get too hung up on this mandatory measure in meeting that minimum volume. And then for the net free area, if you need to show that, this is a little sidebar how to calculate it. And it's fairly straightforward. You look at that gap height or thickness there and the width and how many slats you have, and you do your math magic. Most of you are all math enabling architects. I see a couple smiles there. Yes, hopefully. If not, call your code coach. We'll help you. We're happy to help you. Okay. And then the one thing, though, you might not have in your drawings at this point, or kind of the list of things required when you install a heat pump water heater, and I would think just go ahead and add these, is that the penetrations, if you're doing a ducted system, the penetrations through the envelope need to be sealed, and you need to use R6 ducts, and those could be added as notes. Under our current code, prescriptively, if you're doing the prescriptive option for certain climate zones, like 3, 4, where I live, 13 and 14, and I saw this a lot in climate zone 4. If you installed a heat pump space heating system, then you could use a gas instantaneous water heater. Okay, that was kind of how they made it work out for climate zones where the heat pump water heaters maybe weren't quite, showing that they were cost effective enough. They seem to really be kind of on par in terms of costs with gas, and same with operating costs for the consumer, really maybe $15, depending on how much water you use a year difference. Now that's out as far as prescriptive, and only the heat pump water heater is your prescriptive option. And then you follow all those mandatory measures we just went over. So you don't have to worry about gas if you're doing prescriptive. If you want gas, you got to do performance, a computer model, and look at trade-offs. Water heaters for new construction and additions. This is what we're currently working under. And for those doing really small dwellings, 500 square feet or less, or doing an addition, but adding a second water heater, you had the option of installing an instantaneous electric water heater. Okay, sounds good. Now you have the option of doing an electric water heater, which means you can use a really small, like low boy 40-gallon or 30-gallon if you want, and have a little bit of tank capacity instead of just the electric. So I think that's good. So they made that a little bit easier for folks. However, still, you have to use a point of use, meaning that water heater, whether it's instantaneous electric or not, has to be very close to the sources or to the need for hot water. And you want to take the most direct line. And there is a table 4.4.5 that you're supposed to use for your line size versus your length run. And now under 2025 code, you can use a small tank, or you can still use the tankless. You still have to have you still have to have a point of use. But one thing you will want to do, what's the easiest thing, is to manifold it down so that you can get the smallest line run possible that you need for those fixtures. And then, so what I did was just include kind of an example of what a PEX line system looks like, what their manifold looks like. And the manifold basically just means taking your piping that usually comes out 3/4 inch from your appliance, and you just want to skinny it down right away to 1/2 inch and 3/8 inch. So the insulation for piping and tanks, it's essentially the same requirements. Got to follow the plumbing code, and there's a certain amount of insulation required on your hot water piping. This is a tiny little change, but I want to alert you to it. because the plumbing code changed, sometimes you're going to see a reference to section 609.12 versus 0.11. And so that is just reflecting the newer version of the plumbing code. So if you get in there and you start reading a part of the plumbing code that you're like, this has nothing to do with pipe insulation, go to section 12, and then you'll be on track. You'll just know you're using the newer version of it. So the pipe insulation requirements are still the same in that for your small diameter piping, you take that diameter of the pipe, and that's the same thickness that you have to have for the insulation itself. Okay, for our attics, roofs, insulation, and windows, there hasn't been a lot of changes, but I'm going to highlight a couple of them, and then I'm going to mention what's going on with some code coach questions that we get a lot, and just kind of give an opportunity just to remind folks about when you're comparing your residential building code, roof insulation requirements, and the energy code, how those two kind of fit together. So the mandatory insulation average U factors for roofs, it was new under 2022 code that some of the insulation had to be higher level. That hasn't changed. It's still the same in that if you have insulation under the roof deck and insulation on the ceiling, and the attic is vented and you have ducts in the attic, prescriptively you comply. That hasn't changed. And then if you wanted to use a rigid foam on the top of the roof deck, you had to go to a performance method. That a lot of those are basically the same. And then what that looked like and still looks like is you take a look at your prescriptive roof constructions in our table per climate zone. So our roofs and ceilings, we have something called option B, and that's where ducts are in the attic, and it kind of spelled out how much insulation you needed below the roof deck and how much insulation you needed at the ceiling, and whether or not a radiant barrier was required. And then option C, it's like hardly seems to be too different, except that specifically the ducts are in the conditioned space, and you'd have a HERS person come in there. And if you do that, then you only needed insulation at the ceiling level and a radiant barrier requirement for most of the climate zones. And so, you know, what that basically looks like is the option B says you have to have the insulation right up there at the roof deck, ducts in the attic. And then option B was you could have all your ducts in the space, and you could do it with the air barrier. Okay, so what's new, 2025 code, is on the option C. Basically, this option where you have your insulation just at the ceiling only, climate zones 8, 9, and 10 basically got an upgrade to an R38 ceiling insulation. So for those of you down like Santa Barbara area where you have those climate zones, or at least climate zone 9, that's kind of the update. Otherwise, things are the same. And now what they allowed under this option is that you can now prescriptively just have all the insulation up at the roof deck And again, the air handler and the ducts are all within the conditioned space. And so they just allowed this to be a prescriptive, code compliant method, R38 cavity or an equivalent. And you don't have to use the performance method for that. So the idea was to try and make it easier for folks to just comply prescriptively, because this was a common way that a lot of like ADUs and houses were being built. Where things get a little bit squirrely, well, that's not a technical word, where things get sometimes confusing is we're looking at clients who don't necessarily want a vented attic. They want maybe to have all the insulation up at the roof deck. And these types of assemblies all had to comply with a performance method. Also, it was kind of triggering part of the residential building code, where specifically you had to look at having air permeable or air impermeable insulation, which would determine some of the other components. Now, if you, like these two details, if you do a 2-inch closed cell spray foam at the underside of the roof deck or an R5 rigid insulation on top, then it didn't matter so much what the rest of the insulation was. It could be air permeable or air impermeable. And really the energy code, this is just an excerpt of like what we would put into the software. Really what the energy code is asking is the attic vented or unvented? That's one of the triggers. And where is that insulation located? The energy code doesn't specifically address any condensation potential, nor the amount and area of the attic ventilation or vapor diffusion or insulation types, et cetera, et cetera. Those are all regulated in the residential code. And so this is where we've been getting a lot of code coach questions. So I'm throwing it in here, is you'll want to go to the California Residential Code and take a look at section R806.5 for the unvented attic and unvented enclosed rafter assemblies. And primarily, this whole section was written to try and stop construction assembly techniques that were inadvertently allowing moist air from inside the house to make its way up through all the insulation into the attic and hit a cold roof deck, which is often your structural roof deck, and condense and then cause rot. And they were finding a lot of kind of unsafe structures, essentially, because if that plywood or OSB roof deck can't hold its nailing into the rafters, then they're going to have a lot of problems. And that's the area they would usually rot out, is right at the attachment site. So there is a way to mitigate for that if you use air permeable insulation, and you can design in vapor diffusion ports. And also you can have an attic that's semi-conditioned, where you actually take a little bit of your supply air, if you go with a ducted system, and you actually run some of that supply air into the attic. Now, the part where things get confusing on what the code requirement is that in California, we have 16 climate zones. It just so happens that in California, with those 16 climate zones, we have a climate zone that's called 1 and 2 and 3 and 4 and 5 and 6, 7 and 8. But the ICC that goes across the entire United States, that our residential code is based on, only has climate zones 1 through 8. And the climate zones 4 through 8 are really cold. And are not necessarily applicable to us unless you're up in Tahoe region. And so this is where some of the confusion comes in. So keep in mind that California, especially on our central coast, we're climate zone 3C, and also California climate zone 4, 5, 6, 9, etc., 7. And so based on this, just the R5 rigid insulation is required, or kind of the equivalent of the underside roof deck. And so, but if you go to chapter 7, the walls section, that's where they have the table that gives you the comparison of the ICC code and the California Energy Code. So what happens a lot of times is people are working on their roof and they're looking for a roof assembly that's going to meet WUI, wildland interface, and then they go straight to the section that deals with roofs, and they don't catch or realize that there is a table in chapter 7 that explains which areas of California match up with the ICC code that is referenced for these requirements. And this just gives you a visual of what that can look like. And just one of the easiest ways is really what we call flash and bat, where you use 2-inch closed cell spray foam and then of air impermeable, and then you can fill the rest with air permeable. And I gave you an excerpt on the right so you can look at it. I think when you read it, it doesn't necessarily read very clearly. So these are kind of notes for you just to see, okay, here's what you're reading, and then visually, this is what your detail could look like. And then if you do choose to do an assembly with all air permeable insulation, like all fiberglass or all rock wool or all blown-in cellulose, no foam anywhere, then you're going to have a detailing where you detail for vapor ports, which we're not going to go into for this project. And then the other part of the code, current and continues, is that you can't forget to insulate the heel of the attic. And there's also a vented rafter roof assembly with a smart membrane that you can use. This is another way to mitigate for vapor. And essentially, instead of creating like these small vapor ports, the whole top part of the roof deck is a giant vapor port. And there is a calculation that you have to follow for how big of a vapor port area you have. But if you do the whole roof, like is shown in this project that Mike Horgan likes to do from Karen Collaborative, then you automatically will meet that calculation, and you don't have to worry about any part of the roof having condensation. And you basically are creating an air channel just above the vapor membrane and just below the structural sheathing. And it's the structural sheathing that we're trying to keep ventilated. And for windows, there's just a minor change. So 2022 code right now, you have a U factor 0.3 for all our windows. And now under the 2025 code, well, I say now, I mean coming up in January, 2025 code for climate zones 1 through 5, 11 through 14, and 16, the U factor or U values dropped to 0.27. So the windows have to be a bit better now for those climate zones. Good news is that there's a lot of window available, and the delivery price is not bad at all. And you can get an idea there, even on the double paned, that you can get windows with very low U factors that will meet this new requirement. So it was shown to be cost effective, and this is why, because a lot of window makers, a lot of window manufacturers are now available that meet these requirements. For climate zone 6 through 10 and 15, no change, same U factor 0.3. And then there is an exception, climate zone 5 here in San Luis Obispo, Santa Maria area. We got a little carve out that says if we have new dwelling units with conditioned floor area of 500 square feet or less, we still only have to use the 0.30 for the windows. Okay, battery energy storage.
Hey, Jennifer.
Yeah. Yes.
Hey, sorry I was late. Glad to be here. Before, while we're still on envelope, somebody had eagle-eyed ECC versus a HERS rater. I don't know if you covered that already, but just that name change and when that takes effect. Did you cover that before I got on already?
Yeah, briefly, but no, that's a good question. That's a good note. So if you see me referencing ECC in my slide deck, and that means it's also part of the 2025 code change that's coming up.
All right.
So I was
and
trying
if
to be
it's HERS,
consistent
then that's
with that.
kind of a today thing. Okay.
Yeah, and then I think as we move forward, like, okay, as we start to, you're going to have some projects that are still under this code, which will be called the old code. And then you're going to have projects under the current, which will be, we're calling the new code coming up. So it's kind of interesting. Maybe one good thing about the change in name is if you see HERS, okay, just clarify. Okay, that should be like okay, let me know. Or is it 2022 code we're talking about? And if you see ECC, just make sure. Okay, so you're specifically talking about 2025 code? So, yeah.
All right.
That
Very
might
good.
be
Thank you.
Energy storage systems, battery ready. We currently are seeing it written as ESS in the code. Just heads up, the 2025 code, they've scratched it out and it's BESS, BESS now for battery energy storage systems. But the key concept here is that you only have to be battery ready. You don't have to install a battery in new construction, but it has to be battery ready. And the idea was to increase a household's electric generation and storage system to be able to offset evening electrical grid usage and address resiliency. So the infrastructure is mandatory. It's only applicable to new construction. And then the battery itself is an optional credit. And so you need a minimum battery size of 5 kilowatt hours, which is basically about the size of what you see the in-phase batteries look like there. It's not really big. It's kind of a standard size. Some of them go a little bigger than that as their standard. And it does need to interface with the grid. So meaning these are not off-grid solutions. The idea is that it is connected to the grid and it can add to the overall grid stability because you're able to use the battery when needed. It can also kick in automatically if the grid goes down, but otherwise the whole house is still helping to add resiliency as a community when all of the homes will eventually get batteries. So the battery ready infrastructure requirement, you're going to have a 225 amp main electric panel. You're going to have a sub panel for your branch circuits, and you're going to have an area set aside that sometimes is referred to as a transfer switch, or there's some other names for that piece of equipment that's specific to the battery itself. So you get, a particular brand of battery, and they're going to have their own switch gear or transfer switch, and that space just needs to be set aside. And that piece of equipment, it can be 2 feet wide by 2.5 feet tall, but that's kind of generally the size of some of them. And you would just have a minimum of 4 branch circuits identified that would be a part of this battery system: your refrigerator, at least 1 light, and at least 1 sleeping room receptacle outlet. And then you choose something else that you want. And the raceway is supposed to be installed between the panel board and the system isolation equipment, or that transfer switch, just to allow for the connection of the backup source to be really easy. And then the only change for 2025 code is that they clarified that only the load serving entity with a service greater than 125 amps needs to meet the BESS, or the battery energy storage ready requirements. So if you're building a house with an ADU or a duplex, for example, and one, let's say the ADU doesn't have the service panel greater than 125 amps, that's something, then, but the main house has the 225 amp panel. It just clarifies that you're going to have battery ready on the main house and not the small ADU. Now, if both homes have, if your duplex or your ADU in your house, if both homes have service greater than 125 amps, and it's not just the panel you install, it's the service that you're getting, then yeah, you would need to qualify for the battery ready. And electric ready, it's nearly the same. So you can install appliances that are propane or gas under the performance method. So if you choose to do that for a water heater, a furnace, a cooktop, and a dryer, then you need to make sure that you've got the appropriate outlets and conduit running to those spots, and it's set up in your electric panel so that anyone in the future could easily change any of those appliances to the electric appliance. And then there was a minor change for the 2025, specifically for the heat pump water heaters, just saying that, hey, you need a 30 amp branch circuit requirement for both, whether that water heater is within 3 feet of the gas appliance, or the water heater was going to be located more than 3 feet away from the gas appliance. Under the current code, there was a slight difference in requirement. And so the minor change is they both need 30 amp branch circuit, whether, your allocated space is within 3 feet or greater than 3 feet of the gas water heater. So pretty minor there. And then there's under the 2025 code, that BESS, there's still something called a self-utilization credit, which is the credit you get if you install a battery energy storage system. And they're just updated the definition. But because a lot of folks are opting to install batteries, I thought I would just briefly talk about kind of client expectations, and just because I'm guessing not everyone on the call has a battery and solar associated with their house, so they may not realize that a lot of folks, when they get their battery, get the solar installed, especially new construction, this might be the first time they have dealt with it, and they may be expecting that their house is essentially going to function like zero net energy, and it probably won't. And so the code requirement is only going to hit maybe about 40 to 60% of their needs on the PV panels, on need for the whole house. and you need to add another, double the system almost, and then even double, or then add another 40% for electric vehicle if they're hoping to charge their car regularly. But what's nice is when you set up the battery system, you can, in a lot of cases, depending on what brand and how it's all set up, you can, make sure that your battery's being charged by solar, of course, but also that you can use the extra solar for charging your vehicle, and you can set that up so you could be more self-sufficient. And then only, you could get a credit for 5 kilowatt hour battery, but if you really want to back up your whole house, you might be looking at more than that. So for example, I have solar on my house, and then I just went ahead and said, I just want to back up the whole house because this is existing, and it was, I thought, easier. And plus, I'm kind of nerding out on it a little bit. So I thought it'd be easier and more fun to have 2 batteries so that I could back up the whole house and not have to worry about which circuits were backed up to the battery. Now everything's just backed up to the battery. And then I can tell it to charge my car. Once the batteries are full, all the extra solar, instead of going out to the grid, I have it go to my car and get it charged up. And in most of the days, unless I'm doing a lot of laundry, most of the time, on a daily basis, the solar in the battery is meeting between 90 and 100% of my needs.
Hey, Jennifer.
Yeah.
So we got a question about kind of what's triggering the solar. I know that this class is single family, but focused on new construction. Somebody's wondering if like a small room addition, 100, 200 square feet type of thing, would that trigger the solar energy panels or battery?
No, only new construction. And it could be that you, on your property, instead of an addition, let's say you were building an ADU, that's a standalone, separate, not connected to the main house, that would be considered new construction. And then you would calculate your PV size. And then based on the size of the PV system, that would let you know if the battery systems are triggered or not. And you don't have to use solar is triggered or not. And you do not have to install the solar if the system is 1.8 kilowatts or smaller. So
okay, so additions to existing do not trigger the
no.
Okay.
And then battery still is, no matter what, is optional for credit with new construction, or you just optional because you want it. And then you just comply with the mandatory requirements and electric code, etc.
Right. Okay, cool. Thanks.
Okay, so for heat pump water heating, this is, it was prescriptively required for certain climate zones. Now it's all the climate zones. Heat pump space heating is the baseline and part of the prescriptive requirement. And then the other thing that comes with it is there has to be a heat pump refrigerant charge verification specifically for heat pumps that goes along with this new prescriptive component. And a lot of people are installing mini splits where the outdoor unit has the compressor condenser, and then you've got indoor units. A lot of them are ductless, some of them are ducted, but we're seeing a lot of ductless units, ceiling recessed units, and with the refrigerant line running between the outdoor unit and these indoor units. And a lot of these are variable capacity. So there is a credit that you can get in the performance method when you take a variable variable capacity heat pump credit, which can help offset some other mitigating circumstance. For example, we keep seeing projects in our sort of mild-ish coastal areas where folks don't want to do the exterior insulation on their walls. And so we're looking for credits, and this is maybe a practical way to do it. So that variable capacity heat pump compliance credit, it does trigger some special features. So if you look on your CF1R, your performance, you'll notice under the required special features, there is a call out for the variable capacity heat pump compliance option. And it also triggers a bunch of HERS measures, which will be called ECC measures under the new code. And those are that your verified efficiency, the refrigerant charge, the heat pump capacity, and you have wall-mounted thermostats, or at least, a place to keep that thermostat on the wall and not just lost in between the sofa cushions, for example. So it needs to be, you need to show that it has a place. And that all the ductless indoor units are located entirely within the conditioned space. And this, the best time to have that, like we alluded to it or talked a little bit about it, to verify the refrigerant charge, is when the installing contractor is getting the whole thing connected, hooked up. They should call their the HERS rater, or will be the ECC rater, and see that it's done, and at the same time save those specs, because that HERS rater is going to need them. And the reason I give kind of a heads up is because these things install so quickly. You can 2 hours later and they're gone and on to the next job. Sometimes it's really fast. Okay, so for the variable capacity heat pump credit, kind of the big deal with these is that you need a heat pump indoor unit in each bedroom and the living area, and wall thermostats are required in zones larger than 150 square feet. And the wall and ceiling penetrations for that mechanical system and your condensate lines, all that need to be air sealed. So for the wall mount, that's kind of easy to have it within the continuous air and thermal boundary. But for like ceiling recess, and we're seeing a lot more of these, you would need to spec out or, consistently call out how these units are going to be within the conditioned boundary. So if you're doing the attic floor insulation only option, then you're going to need to create a box around the recessed unit. So taped and sealed drywall acts as a great air barrier, and the insulation can go up and over the top of it. Or if you're going to do an assembly where you've got all the insulation up at the roof deck, then that, especially if you do the spray foam, and that becomes your air barrier, then you can just install this unit up in the open attic space. It's very clean. You could get to the condensate lines. They could set it up very cleanly, and it's within the air and thermal boundary. And then you get credit for that. Okay, for our last kind of section here with indoor air quality ventilation.
Hi, Jennifer.
Yeah.
Before you jump into IQ, I got a question. Is the R5 rigid insulation over the roof sheathing?
In that case, yes. I drew it that way. It's technically, you could put it between the rafters under the roof deck, but we don't recommend it so much because it's almost impossible to get an air seal between a piece of foam that you've cut by hand and wood rafters that are imperfect material. So then you have to do a lot of extra work, including with foam sometimes and caulking, to make sure that all those are sealed in place. So technically you could do it. We don't recommend it from a construction, just production perspective. You're better off just using whole sheets of foam, rigid foam on top of the roof deck and taping and sealing them, or going with like a spray foam, or doing one of the open vapor port type of assemblies. So, okay, indoor air quality, IAQ. This section, it really tries to align the energy code with the ASHRAE 62.2, and it's still the basis. 62.2 is still the basis for these mandatory measures. We've got kitchen hood exhaust, bathroom exhaust, and then our outside air requirements. And these mandatory measures are required for all new construction and additions greater than 1,000 square feet. So here, we'll talk a little bit more when we do the additions, alterations, but just kind of FYI, if you do add on at least 1,000 square feet, then you're going to trigger some of these requirements. So mechanical exhaust is required for kitchens and bathrooms. It's usually a local mechanical exhaust. We've got certain requirements that are triggered for open or non-enclosed kitchens, and then others for enclosed kitchens and bathrooms. You can use a continuous ventilation system that is part of the energy or heat recovery balanced ventilation system. And then just a reminder, all these systems need to be able to be turned off and switched off. And your idea is you leave it on, but at times of really poor outdoor air quality, then you can turn it off, and they should be labeled as such. And that part of the code hasn't changed. And current code, and this part hasn't changed, is that the quantity of CFM kitchen range hood will vary depending on the size of the dwelling unit and whether the range is electric or induction, which is also electric, or if it's natural gas or propane. So if it's a gas, you need more ventilation. This is just an illustration of a 65%, just called capture efficiency. And that is a rating that some of the kitchen hoods are now doing. It's not all of them have that rating, but the ones that do, then you're going to look for a certain capture efficiency or a CFM requirement. For 2025 code, it's just a tiny clarification, which is to say that if you're going to do a downdraft, it shall be 300 CFM for enclosed or non-enclosed kitchens. And then they just separate it out, saying continuous local exhaust for enclosed kitchens shall be 5 air changes per hour. And it's based on that enclosed kitchen volume. So they just tried to clean up the code.
Hi, I got another question on the chat from Gian. Can the range hood be replaced by the other exhaust fan, not downflow, but a ceiling fan?
Yes, if I understood that question, could you repeat it?
Can the range hood be replaced by the other exhaust fan, not downflow, but a ceiling fan?
You could. I mean, if the ceiling fan if you're able to prove that you are meeting the CFM for that space, and it's all being taken out of the room, it could be wall, it could be a through the wall, it could be ceiling and out. It's just that with a range hood or a downdraft, the idea is that it's capturing all the particulate matter and all the part that makes breathing the fumes of cooking not healthy. It's known to have a very strong correlation with cases of asthma. So a lot of EPA study went into that. So yes, you could do it, but think it through to make sure you are meeting those requirements and that you're really making it a clean space. Now you could do that continuous exhaust like all the time. And that's acceptable. And then there's going to be like this slide right here, just as giving you the mandatory measures. It's a prescriptive mandatory, meaning you have to do it and you can show it prescriptively, which is that you, for example, that duct length should be less than 25 feet. That's taking that exhaust fan, no matter where it's located. And you shouldn't have more than 3 elbows, et cetera, et cetera. You could do that, or you can have the airflow tested by your HERS rater, for example, one or the other. And that's kind of the main thing. And sort of goes back to that question, is just making sure you've got enough exhaust in general. Now, I threw this slide in here. This is a prescriptive requirement, and I just don't want to conflate the idea of what we're talking about with the whole house ventilation and IQ with ventilation cooling, which is a prescriptive requirement for climate zones 8 through 14. So this concept here is where you know it's colder outside, it's summertime, the temperature's dropped, you open up your doors and windows and you turn this fan on for a short amount of time, and it pulls air through the open doors and windows into your attic and then pushes the hot air out of your attic. Okay, so that you could do that, and those are a different set of requirements, not to be confused with these other exhaust fans we're talking about. So the requirements itself for how much ventilation IAQ you need, so not the cooling, but just like the continuous fan running or the intermittent fan running. This equation follows ASHRAE 62.2. So there's a factor you multiply times the floor area plus 7.5 times the number of bedrooms you have plus 1. And this will give you a real good estimate of how much fresh air, outside air you need. And in some cases, it could be a little less than this, depending on how you want to calculate it with air infiltration through the rest of the house. If you have a really leaky house, you don't need as much. But this is a good place to start, especially with the architects. And now we're seeing more and more folks going with a balanced ventilation, often with a heat recovery or energy recovery. And so what that means is there is a heat exchanger within the fan unit. And so you're pulling air from outdoors and pulling air from interior and ejecting, one stream into the house and one stream back outside. And the heat and the energy can transfer from one stream to the other. So it gives you some energy efficiency. We don't get quite so much credit in our mild climate zones, but we are seeing it just as a better way to meet the indoor air quality. So there are certain client expectations. I put this sheet in to kind of remind folks that there are accessibility issues with, can the homeowner access these units? Because supply only, ERV, or balanced with the supply, and HRV, any of those, they require a MERV 13 filter. And you have to be able to get to the filter and change the filter. And some of the units have a pre-filter. So they have to be able to get to that. And also they need to be able to maintain and inspect the ports for where these ducts are pulling the outside air in and when they're where they're exiting them. So these are some questions to kind of go over and to look at and to think about when you, as an architect, where are you putting this equipment, or where are you hoping it's going to go, and how is your client going to access them and maintain them? And it is currently, and I'm saying used to be because I'm already jumping into January. No, currently you could get, some credit for this. You could have, it can trigger a HERS inspection. And this table is kind of gives you an idea of some of the requirements with like screen shall be greater than 3/8 inch holes, for example, so that the flow itself isn't impeded, or you're going to have to, redesign that airflow to make sure it meets the piece of equipment, and that you need some of these, like the outdoor intake, needs to be accessible and within 10 feet height of a walking surface so that people can get to it. There's some other additional requirements in the mechanical code that you need to follow if your outdoor air intake is on the roof. And then the filters, the heat exchangers, etc., need to be serviceable. And there's some requirements for that. So a lot of this that you could get credit for is now going to be mandatory in 2025. And so one of the things I think I found kind of interesting is on the mandatory requirements now is if you do locate your HRV or ERV or that fan system in the attic, you would have to have a fault indicator display. So you need special controls so that you can see if anything is wrong with it. And then also you would have other sort of requirements in the attic, like an easily accessible hatch, or maybe you have a second floor that opens through a wall into the attic, and then a walkway that goes from that access path to the equipment. So they really, the downfall of these things is people not being able to get to the filters and doing the maintenance. So some of the brands say, like the one on the left is a Panasonic, and you maybe see lay it down, it's just a fine mesh. It's just laid down because it's like this pre-filter. And so you can just rinse that off with water, and they recommend you rinse it like every month. And then there's your MERV 13 filter, which you can vacuum. And the core, sometimes you can vacuum those. And so you really need to be able to access these. And then the easiest way probably is, and then again, this is like as an architect, you're going to design a location for it. So in this particular multifamily project, the architect designed a small closet with a louvered door that can be open, and then you can get to it, change the filters, do the maintenance as needed. And then what I did for you is to include this, the actual language, since it's a new section, and just for your reference. And it does indicate, does go back and forth a lot to what is required in the mechanical code and reference appendices. So that was those manuals in the very beginning I was showing you, where they'll also have a bunch of requirements. And this really, it's to have these things function properly. So what we've learned, kind of big picture, on heat pumps, ductless mini splits, the indoor units, people forget that there's screen filters that need rinsing about once a month. And your heat pump water heaters also have a similar screen filter that needs periodic maintenance. And you'd be surprised, even some of the best builders I know, every once in a while, it'll get past them, and the plumber doesn't realize that there is an area on the top of the tank where that filter comes out. And I just saw one like this just last week, where sorry, it wasn't the plumber, but the part of the tank for all the electrical connections were taken off the top of the tank and right into the wall, and it looked like a super efficient job. Why have a lot of extra electric conduit? But they did it so snug and tight, you couldn't get the air filter out. So they had to come back and redo it. And then with the ERVs, even with your supply only equipment, they also have pre-filters and MERV 13 filters that need to be changed and cleaned. And with that, if you have more questions, the Code Coach service is available, and we'd love to answer your questions. There's some upcoming courses that Danica is going to talk about, and I hope you enjoyed it, and let me know if you have any other lingering questions or if Danica needs to get us off the call. And if you have to drop off because of the time, yeah, feel free.
Yes. Thank you so much, Jennifer, for delivering another great course, and Andy for joining us today to monitor the chat. And thank you everyone who attended today. If you have questions in receiving your AIA or ICC units, please reach out to me through my email, and we will be sending an email in the next couple of days, which will include the recording of this course, the slide deck, and a survey. We encourage you to fill out that survey to give us a better direction on what y'all are interested in, and we are always developing new training, so if there's any topics of interest, please include that in the feedback as well. And I want to highlight our regional forum happening on April 30th, Building for the Future, Preparing for the 2025 Energy Code, where Jennifer Rennick is actually one of our speakers in the forum. And also, this slide includes the rest of the Energy Code implementation series, our single-family additions and alterations, ADUs, and multifamily, and the dates are listed on the slides. And with that, I'm passing it back to Jennifer and Andy for any questions. And I actually got a quick question on the chat. This one's regarding the IAQ and whole house fan. Is there a best place to put IAQ or whole house fan near the kitchen or living room? I learned that it should be accessible to replace, sorry, that's the second part, but where the best place to put IAQ or whole house fan?
If the whole house fan is if it's like a single fan and it's a ducted system, then a lot of them have 3-inch ducts, and you can, run that, you run those ducts into every room. If you're talking about the fan itself, like a ducted system, you could put those in utility room. You can put it in a basement space if you have it. I've seen them located in utility closets, like between the garage and near your washer dryer, right? Because they do have a fan, they make noise. So there's that. I've seen them off of hallways, but if your space is big enough, I wouldn't put them close to bedrooms just because you'll hear the fan.
And Jennifer, it sounds like it may be a question for a non-ducted system where you have a unit that's providing whole house ventilation as a kind of a central unducted system. Is there often we see those in bathrooms, right, that provide whole house ventilation and then pop up?
Oh, right. If you're doing like an exhaust only system, or if you're doing a balanced where you've got exhaust plus supply. So I've seen it where the supply fan is accessible and sends that air, which is unconditioned. If it's not an ERV, it's just supply, like into your utility room or a laundry room. And then you let your bathroom fans run intermittently. And at the same time, they can be smart switched together so that the supply fan comes on and then the bathroom fan exhausts, and then they're separated, which induces an airflow through the space. So you want to just think about that and how your doors are open and closed as well. Sometimes the supply fan goes into hallways, and then they've got Mike tells me about a project where they did the supply into a hallway and they did some exhaust into teenager bedrooms, which the clients were very happy about. I hope that answers it. Maybe it's nuanced, or we can look
Right,
at
it's
it.
almost like negative pressure for like you might see in a clean room, like the teenage room. That air has to, everything's going in and it's exhausting from there.
I know, I saw that and I was like, that's an idea. I think, okay, retrofit on my.
Right, you with teenagers at home still. And it looks like kind of a follow-up maybe for that IAQ fan that you showed on the slide. It was a ducted fan. I can't remember now which fans you were showing. I know you did show a ducted one at some point. Oh,
Yeah,
there's an HRV that's probably in a hallway, right?
Yes, this one, let's see, can you see the mouse? This one's in a hallway. And this type, this one is really, it's upside down in the sense of it's here at a trade show, so you can see where the filters come out. But that would be like this kind of a location where this panel pops off and you can get to the ERV below. And this is really similar concept to a lot of the supply fans, the supply only fans that have the MERV 13 filter. So like in this particular house, they opted to put it in this was going to be a small little wet bar, and they had like a game room, and then it could double as a guest room when they needed it. But that way they were getting the heat exchange and the continuous airflow where they wanted it near this little efficiency kitchen or / wet bar and game space. So those are the kinds of things to think about. The ventilation isn't really a big number. It's really pretty small. And one of the builders we work with for retrofits, because there really isn't like a code requirement on it, you can use through the wall ventilation systems too, where they operate in pairs. But for getting credit for new construction, the fans themselves has to be HVI rated, and just some of those through the wall spot ventilation systems are not yet. But this Panasonic spot ventilation is, and like this is a Panasonic unit, but the Brone makes one like it where it's a supply only. You've got a pre-filter and a MERV 13 filter. You just have to set it up, and a control panel is right in here. And it doesn't have the heat exchanger, but at least it gives you filtered air. If you dump that into your kitchen, you might not mind it. If you dump it into your laundry room, that might be great because your laundry room might be stuffy. You might need fresh air. You just have to think about where that cold air would be coming in during, during some of the times where you wouldn't want colder air or hot air blowing on you. That's kind of the main thing. That's what's nice about a heat exchanger, but the price goes up a lot more. But these are better ways. The balanced ventilation and the HRV, ERV systems are better ways to meet the indoor air quality part of the project, because with just exhaust only bathroom fans, which is really common, least expensive way, we are counting on the wall assemblies and roof assemblies and the detailing around our windows and floors to be very leaky, right? Because you negatively pressurize the space. So we're pulling we're pulling air through those assemblies that we were trying to have built in a way that acted as a thermal and air barrier from the first place. So as the construction improves, then we want balanced ventilation systems. And these are the two most common type: a supply combined with your exhaust fan, or the ones where it's combined HRV, ERV. Okay, I hope that helped.
Yep, that helped. Thank you. Any other questions? You can also just unmute. We're a small enough group if you had a question or comment. Otherwise, we'll close up shop here. All right. I don't see anything else.
Okay, think we're good then.
All
Yeah,
right.
thank you
Thanks,
so
everyone.
much,
Have a great
everyone.
rest of your day.
Thank you. Bye.
Goodbye, everyone.